Lesson 4-3, Congruent Triangles. Some vocabulary terms to keep in mind: congruent, which means equal to or the same as, congruent polygons, and corresponding parts. Why is it important to be able to identify corresponding parts of congruent triangles, and why does letter order matter? Well, if a triangle can be translated, rotated, or reflected onto another triangle so that all of the vertices correspond, the triangles are congruent triangles. That means they have the same angles and the same length sides. They have equal measures. The parts of congruent triangles that match are called the corresponding parts. The order of the vertices indicates the corresponding parts. That says triangle ABC is congruent, and we know the congruent symbol, to triangle XYZ. Well, A corresponds to X. That means angle A and angle X have the same measure. B corresponds to Y, which means angle B would have the same measure as angle Y. Angle C corresponds to angle Z, which means that they would have the same measure. You don't even need a picture to know what is congruent, because just with this one congruency statement, so this is called a congruency statement because it has a congruent symbol in between, this congruency statement tells us what is congruent, and I can draw my own picture. So here is triangle ABC. I have just created triangle FDE that is congruent to triangle ABC. The order of the vertices indicates the corresponding parts. So I have my congruent triangles. I have angle A. Well, angle A is going to be congruent to angle F. I also know that angle A is congruent to angle F because they are in the same position in my congruency statement. I can also tell because this now has one arc and this has one arc. If I have angle B is going to correspond to angle D, and again, angle B is in the same location as angle D. I also know, because I have now marked, that this has two arcs and this has two arcs. Finally, I have angle C, which will correspond or be congruent to angle E. In addition to finding congruent angles, I can find congruent sides. Congruent sides, if I say I have segment AB, then I'm going to know that that corresponds to segment FD. Notice A is one arc, B has two, F has one arc, D has two, so the order matters. If I go from A to B, then I have to keep the same order in the congruent triangle and go from F to D. Again, if I look at my statement here, AB is first and second, FD is first and second in the second part of the congruency statement. So if I have BC, that means I'm going to have DE. If I start at B and I go to C, 2 arcs to 3 arcs, D is 2 arcs, E is 3 arcs. Finally, if I go from A to C, notice I reversed my order. If I go from A to C, then I need to go from F to E. These relationships help define the congruent triangles. So, definition of congruent polygons: 2 polygons are congruent if and only if their corresponding parts are congruent. So we just proved it on the picture, but I know if A is equal to H, so this is going backwards. So on the previous slide, I was given a congruency statement and asked to list what's congruent. Here I am being told A is congruent to H, B is congruent to J, and C is congruent to K. That lets me know that my corresponding sides, A to B, is going to be congruent to H to J. B to C is going to be congruent from J to K. A to C is going to be congruent from H to K. And since all of my angles correspond and all of my sides correspond, I can write a congruency statement. You are going to be asked in this section to write statements about the angles and the sides, but you are also going to be asked to write congruency statements. A congruent statement is when you say one triangle is congruent to the other. And again, notice A is congruent to H. A and H are in the same position. B is congruent to J. They both come second. C is congruent to K. They both come third. If you change one over here, you need to change the corresponding angle over here. So show that the polygons are congruent by identifying all the congruent corresponding parts. Then write a congruent statement. Now, nothing here is marked congruent. That's why we're doing this as an example. But if I want to list all the parts that are congruent and then write a congruent statement, I'm going to start with the angles. Angle A, which is right here, is congruent to angle R. Angle B is going to be congruent to angle T. Angle C is going to be congruent to angle P. Angle D is congruent to angle S. And angle E is congruent to angle Q. I also have to list the sides. A to B, segment AB is going to be congruent to RT. Segment BC is going to be congruent to segment TP. Segment CD is going to be congruent to segment PS. Segment CD is going to be congruent to segment PS. Segment DE is going to be congruent to segment SQ. And finally, segment EA is going to be congruent to segment QR. This allows us to write the congruency statement that pentagon ABCDE is congruent to RTPSQ. A and R match up, B and T match up, C and P match up, D and S match up, and E and Q match up. Here is an example for you to try. The reason that D is correct is because if I go through each of these, it says A, B, C is congruent to D, E, F. When you are faced with a problem like this, mark it. A is going to be congruent to D. B is going to be congruent to E. And C is going to be congruent to F. And since this is multiple choice, angle ABC is angle ABC is congruent to angle EFD. Well, this has 2 arcs, this has 3, so I know that it can't be A. Angle BAC, congruent to angle DFE, well, this has 1 arc and this has 3, so they are not congruent. B to C would correspond to E to F. 2 arcs to 3 arcs, 2 arcs to 3 arcs, so that rules out C. AC would correspond to DF, and therefore that is the only one that works, which is why D is correct. Here we know that triangle RST is congruent to triangle XYZ, so we want to find the value of N. If I take the fact that these 2 triangles are congruent, my next step is to identify the corresponding parts. Well, angle Y is going to correspond to angle S because S and Y are both in the middle. Therefore, I can write the following equation. Angle S is equal to angle Y. 50 is equal to 2n plus 10. I subtract 10 from both sides, and then I divide by 2, and n is equal to 20. In the diagram, triangle ITP is congruent to triangle NGO. We want to find the values for x and y. So I corresponds to n, T corresponds to G, and P corresponds to O. So the first thing I notice is that 6y minus 14 is going to equal 40. Because angle O is congruent to angle P, and congruent parts of congruent triangles are congruent, and because corresponding parts of congruent triangles are congruent, O is equal to P. Therefore, 6y minus 14 is equal to 40. And if I look at my picture up here, I add 14 to each side and divide by 6, y is equal to 9. Now I want to look, 7.5, x minus 2y is a side. Well, I'm not going to start with that because that has an x and a y in it. But I know that NG is congruent to IT. So I can say that x minus 2y is equal to 7.5. I just found that y is equal to 9, so I substitute. I'm now going to add 18 to both sides, and I get that x is equal to 25.5. And even though 25.5 has a decimal, that is my correct answer because decimals happen. Now it is your turn to find x and y. Third angles theorem states that if two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangles are congruent. Well, this comes down to the fact that if there are only 180 degrees in a triangle, if C and B are equal to K and J, if C is 50 and B is 70, and then I make this 70 and this 50, well, 50 plus 70 is 120, and 120 minus 180 is 60 degrees. And it doesn't matter whether the 60 degrees is A or L. There's only 180 degrees in each triangle, which means that if these two angles are the same, mathematically it's going to be 120 no matter what. And this is true regardless of the measurements of angles B and C and K and J. Here are some properties of triangle congruence. The reflexive property, which states that an angle or a triangle is equal to itself. This can also work for angle A is congruent to angle A. The symmetric property, which states that triangle ABC is congruent to triangle EFG, or an angle is equal to another angle, and then if I reverse the order, it doesn't matter. It's not like the chicken and the egg. It doesn't matter who came first. The transitive property allows me to substitute over multiple triangles. So triangle ABC is congruent to triangle EFG. Triangle EFG is congruent to triangle JKL. I can say that ABC is congruent to JKL. And that goes away. It's like saying if I have a dollar bill and I have 10 dimes, well, 10 dimes also equals 100 pennies. A dollar equals 100 pennies. Here are some examples for you to try. Please keep in mind that you need to keep the points in the correct order. Here is another example. Please note that you can answer this without a picture. A, B, and D, E are in the same positions. That makes them congruent. Please note for this example, you are only finding X. Please note for this example, we are finding the measure of angle A, not just Y. That concludes the lesson on 4.3 congruent triangles. Don't forget to bring any questions you may have to class.